I thought I would go through a few of the homework problems from 5.1 to make sure that you know what you're doing. So here is 5.1 homework problem number 1, and it's asking us to determine whether Rolle's theorem can be applied to the function on the closed interval. If Rolle's theorem can be applied, find all values of x equals c that satisfy the theorem, or explain why not. The first thing you need to check is that you have a continuous function on the closed interval -2, 5 and differentiable on the open interval -2, 5. And since this is a polynomial function, we know it's continuous for all x values and differentiable for all x values. So the next thing we need to check is that the f of -2 equals f of 5. So we're going to calculate f of -2. So -2 squared minus 3 times -2 minus 10. So that's going to be 4 plus 6 minus 10. 10 minus 10, that's 0. And now let's calculate f of 5. 5 squared minus 3 times 5 minus 10. 25 minus 15 minus 10. 10 minus 10, 0. So that is good. F of -2 equals f of 5. And now we need to calculate the derivative of f. So f prime of x is 2x minus 3. And we need to set to c minus 3, right, f prime of c, equal to our f of 5 minus f of -2 divided by 5 minus a minus 2. So 2c minus 3 equals, remember this will always be 0 if you can use Rolle's theorem, because your f of -2 and your f of 5 are equivalent, so 0 over 7, but that's still 0. So we would add 3 to both sides and divide by 2. And there is our c value. So we found our c value where this is telling us, since we're using Rolle's theorem, we know that that's where the vertex is, and that is where the minimum is. Because remember, it finds your maxes and mins. So on this one, I'm just going to go over to the side. So number 1, try and do this. F of x is continuous on -2, 5. F of x is differentiable on -2, 5 because it is a polynomial function. And I'm running out of space here, guys, so that is the reasoning for 1 and 2. Your number 3 actually was all this. So lastly, by Rolle's theorem, x equals 3/2 is where there is an absolute minimum. And we know it's an absolute minimum because we know it's a minimum. We know it's a upward facing parabola, so it doesn't have any other minimums. It's an absolute. All right, so let's go to number 2. There might be a problem with number 2. Let's take the derivative. I'd bring the 2/3 down times x to the 2/3 minus 3/3 negative 1/3. So when I look at this, your derivative is undefined at x equals 0. And that means since 0 is in your interval, that means you don't have continuity. Well, you might have continuity, but you definitely don't have differentiability. I think this is actually a vertical tangent. I'd have to put it in my calculator and look. But I think we've got a vertical tangent going on at x equals 0, meaning that it would have continuity from -1 to 1, but it wouldn't have differentiability from -1 to 1. So we could check to see also, if you wanted to, you've got -1, you've got the cube root of -1 squared minus 2. And so the cube root of -1 is -1, squared is 1, minus 2 is -1. And this one would have been the cube root of 1 squared minus 2, 1 squared minus 2, -1. So this would have held up. They both, f of -1 equals f of 1, but no, Rolle's theorem does not apply. Because f of x is not differentiable at x equals 0. So you actually didn't have to do those because I already knew that the derivative wasn't going to work, but I just thought I'd do it just to show you. Okay. And so you're going to be doing the same thing here on number 3. You know the sine function is differentiable and continuous. Continuous on the closed interval, differentiable on the open interval. So you could say, well, first, f of x is continuous on 0 to pi. F of x is differentiable on the open interval 0 to pi. The third thing, you need to calculate f of 0. Sine of 0 is 0. We know that from right here on the unit circle, the 0.10 cosine sine. And then f of 2 pi, sine of 2 pi, that's 0 and 2 pi, so that's 0. So you know your f of 0 equals your f of 2 pi. So we can apply Rolle's theorem. So we could say, yes, Rolle's theorem applies. And now we need to take f prime of c and set it equal to f of 2 pi minus f of 0 divided by 2 pi minus 0. So we know our derivative of sine is cosine, so this would be cosine c, right? Because our f prime of x is cosine x, so our f prime of c would be cosine c, and we know this is going to be 0. So we're looking for the angle at which, when I take the cosine of that angle, I'm going to get 0. And we know that the cosine is 0 at pi over 2. That's the 0.01 cosine sine, and at 3 pi over 2. So our c is going to be at pi over 2, and 3 pi over 2 is where you're going to have 0. So again, I'm going to try and write over here somewhere. I don't know where. This is finishing up number 3. What did I say? Okay, by Rolle's theorem, x equals pi over 2 and x equals 3 pi over 2, is where there is an absolute maximum and an absolute minimum, respectively, on 0 to pi. Because you would have been talking about just that little piece from 0 to 2 pi of y equals the sine of x. And right here, at pi over 2, you have your maximum. 3 pi over 2, you have your minimum. Okay. This one on the interval from 1 to 3, number 4, looks fine in terms of there's not a discontinuity, because that's only going to happen if it were 0 or negative. So the next thing we need to check is, does f of 1 equal f of 3? So 1 minus 2 times ln 1 would be 1, because ln 1 is 0, so that would just be 1. F of 3, 3 minus 2 times ln 3, okay, that's not going to be 1. So you're going to say no, Rolle's theorem does not apply. Because f of 1 does not equal f of 3. So that has to be something that you have to use Rolle's theorem. Okay, number 5 is where they start doing mean value theorem. And the mean value theorem is very similar to Rolle's theorem. It's just that the f of a doesn't have to equal f of b. But you are still looking for where the derivative is the same as the slope of the secant. So first thing you need to check is f of x continuous and differentiable. So f of x is continuous. This is a polynomial. And continuous on the closed interval. And then f of x is differentiable, because it's, again, a polynomial on the open interval. And I'm going to say because, probably shouldn't use the word it. Let's use the word f of x is a polynomial function. And then number 3, calculate your f of negative 1. Negative 1 cubed minus negative 1 squared minus 2 times negative 1. Negative 1 minus 1 plus 2. Negative 2 plus 2, 0. And then we'll calculate our f of 1. Oops, lost it. Which is our 1 squared, or no, cubed, sorry, minus 1 squared minus 2 times 1. So this can be 1 minus 1 minus 2, negative 2. And remember, they don't have to equal when we're using mean value theorem. So that's fine, that one of them is 0, one of them is negative 2. we need to find our derivative, f prime of x. So that's going to be 3x squared minus 2x minus 2. And usually we just make it f prime of c. And then we're going to set our f prime of c equal to our f of 1 minus f of negative 1 over 1 minus a minus 1. And we said that f of 1 was negative 2 minus 0. F of negative 1 was 0 divided by 1 plus 1. So this gives me negative 1. So I've got 3c squared minus 2c minus 2 equals negative 1. And I'm going to add 1 to both sides. 3c squared minus 2c minus 1 equals 0. And now let's try to factor. 3c, c, 1 and 1. We want negative, positive, because if this is a negative 3, positive 1 gives us that negative 2 in the middle. 3c equals negative 1, c equals negative 1/3, c equals 1. Since our interval is negative 1 to 1, we're going to, because it's supposed to be, this c value is supposed to be between negative 1 and 1, not at an endpoint. So we can throw this one out and just focus on c equals negative 1/3. And so mean value theorem can be applied. So you didn't say that. Yes, the mean value theorem can be applied. Excuse me. And therefore, c equals negative 1/3 on the interval from negative 1 to 1 is where the slope, of the tangent line is negative 1. Because remember, we were looking for, this is the slope of the secant line up here. So slope of our secant line was here. It was negative 1, and we were setting our derivative equal to that right here, because we wanted to know, hey, where is, for what c value, and we found out c equals negative 1/3 is where the slope of the tangent line is equivalent to the slope of the secant line. So if the slope of the secant line was negative 1, it's where the slope of the tangent line, is negative 1. Sorry. Thought I still had yellow on there. Okay. So these are long. I guess you're not really going to be able to fit them on your paper. You might have to just do them on regular paper. I guess I'm going to let you try and do some of the rest of this on your own. Email me if you have any questions or